Welcome to this episode of At Home with APS. Hi, my name is Mrs. Gaudette, and I'll be working with you with Miss Sears through 3rd, 4th, and 5th grade math. Just as last week and yesterday, we'll be doing a routine to work on our number sense. Then we'll be moving into a task that's working with fractions. Then we'll be moving into a fun book with cookies and following up with the Pigs Will Be Pigs from yesterday. And then lastly, we're having a game that has a spinner, and we're going to show you another way to do a spinner. So let's start with our routine. Today, we're going to be doing a number of the day activity. You're very similar to what we did last time, but with a few little tweaks. So our number of the day is 18,837. Reminder, I'm not saying an and. And do you guys remember why you can't say the and? Right? It's the decimal point. It's saying there's some numbers behind it. So if we said an 18,000 and, that would actually mean it's 18 and then some a little after that. So please have a sheet of paper, your spiral. If you're with us every day, please have that spiral out. Have something that you're going to be doing the work with me. Again, call out your answers. That would be perfect. So we have placed the digits in the correct place value chart. Let us start with the ones. How many ones do I have? 7. So let's make sure to write that in. How many tens do I have? I have 3 tens. How many hundredths? Right? So we have 8 hundredths. How many thousands do I have? I have 8. Thank you for calling out those answers. I really do appreciate your help with this. How many 10,000s do I have? I have 1 10,000. All right. I added in something this time because I realized I was like, we're doing all this and I just rewrote the number. Woo, I don't even know what that means. Yay. So what I did is, what is the value of each? So if we look at this and we have our ones, what is the value of that 7 ones? I'm actually going to draw a line here for myself. The value, thank you. The value is just 7. There's no more, no less. There's 7. How many tens do I have? I have 3 tens, which is how much? 30. Yeah. All right, we're just making sure you have all these numbers and what this really means to us. So I have 8 hundreds, 8 100s. So thinking about that, how much is that worth? 800. You got it. Thousands. We have 8 thousands, 8 1,000s. I say that one in there because it helps me separate and understand that I have 8 of that group. Yep, thank you. It is worth 8 thousands. And then how many 10,000s do I have? I have one group of 10,000 or 10,000. All right. So this is just a quick reminder of what that place value is worth. Now, last time I asked you that question is, would you want, I think our number was like 3,789, something like that. And I said, I would want that. Would you want that or would you want this? Do you remember what my question was? I'd want this one with money, right? If I had money. But if I had 18,837 pennies, or would I want $3,789? Which one's worth more? The dollars is worth more. But if we had just $18,837 or $20 bills, $100 bills, that would be great. All right, let's go ahead and let's move on to our next one. Now we're going to, again, write it in our different forms, our standard, our expanded, and then our word. So standard form, do you remember what the standard form is? Good job. It's just the number. So we have 18,837. Be precise with me and let's really practice not saying that and. All right, the expanded form. That's where that extra work we did, the value of each one, will help us out. So what is the expanded form for 18,837? This time, we start with the largest number. And how much was that? 10,000. So we have 10,000 plus, what was the next value? 8,000, right? We have 8,000 plus the hundreds, 800, and then keep going with me. What is the next one? The tens place value, 30, and the ones, 7. All right. So now we write it in word form. Remember, in word form is how we would say it. So I'm very, very old school. I still write a few checks. Most people don't write checks anymore. But when you write a check, you have to go ahead and write it in standard form. And then underneath it, you have to write it in word form. The bank wants to really know if what you wrote up there is what you meant. So we got it sometimes, not always, because not everyone writes a check anymore, but we have to write it in word form. So if we say it 18,000, so we write out 18. Oops, I didn't mean to do the dash. Do you know why I didn't mean to do the dash? Because normally we don't write it like that. Normally if I have something else, I would write it like that, but it's just, actually I think it might be the dash. I don't remember. Yeah, I think it's the dash. Now I'm mixing myself all up because I'm trying to talk through it.
I think it's just the straight word.
It might be the straight word. Okay, thank you, Miss Sears. All right, 18,000. And then I put a comma. And because that comma is I'm just moving into the next part of the word. 18,800 800, and then I put a comma, and the last part is the 37. Then we have 30. Now comes the dash. See, I knew I was confusing myself. 37. So we have the way we say it is the way we write it. 18, now it's gonna bug me, that dash in there. 18,837. Remember, no and. Okay. The next activity asks us to, what is the sum of the digits of today's numbers? How do I figure out the sum? Good, we have to add. What do we add? We add all the digits. So I have a 1, an 8, an 8, a 3, and a 7. So we have to add all those digits. So I'm gonna add them. 1 plus 8 plus 8 plus 3 plus 7. All right, equals. All right, I know my doubles. So 8 times 8, 8 plus 8 is 16. That will help me. So I have these two. And then I know to get from 16 to 20 is 4. Did you guys see the 3 and the 4? So I can add that. I have 16. I have another 4 more, which is 20. And then add the 7, 27. So remember, you guys, you don't have to, in addition, we don't have to go straight in order. Sometimes in order of operations, we have to go in a certain order. In addition, we don't need to. Whatever makes it easier to add all the numbers. So we have 27. All right, this is the next one I can't wait for. I saw this somewhere, and I really liked how this one was. So rearrange the digits in today's number to make the number with the greatest possible value. Then add that number to today's number. So I'm going to put today's number in here since we know we're going to have that. We have 18,800. Did you guys see what I did wrong? Yeah, I didn't even look there. Let me erase that. Let me undo. So we have 18,000. Are you saying it with me and writing it down? I hope so. 18,837. If I was to go ahead and find the greatest possible value, help me out here. What would I have to start with if these are my digits? Remember, I can take those digits and rearrange them. All right. So if I had to have the greatest, what kind of number would I need to go for? The biggest, right? So what is my largest number here? 8. So I'm going to start with 8. Then if I'm doing this, my thought process is I'm just going to keep going with the next biggest number all the way down. So if we have 8, what is my next biggest number or largest number, digit? 8 again. And then from there it would be 7. Then from there we only have the 3 and the 1. Which one's larger? 3. And then that leaves 1. And then what we were asked to is to add the numbers. So let's do that. What is 7 plus 1? 8. What is 30 plus 30? Because remember, we're talking about this place value. It's 60. So we have 6 tens. That's why we did that place value chart to talk about that. Now we have 8 or 800 plus 700. What is that? We have 1500s. 1500s. Well, I only have place for one of those digits. So we would go ahead and put the 500, and then we have that 10 hundredths that we're going to have to plop over and carry. Now, how do you say it again, Miss Sears? I always say it wrong. It's regroup. I would have to regroup that 10 100ths to 1 1000. And then we add these up. We have 8,000, 8,000, and 1,000. We add those together. We get 17,000. So I'll put my 7,000 and regroup that 10 1,000s over. And then we have 80,000, 10,000, and 10,000. If we add all that, we get 8, 9, 10, 10, 1,000, 10,000s. Oh my place value is getting off on me. 10,000. So I have to regroup that. And we end up with, if I put in my comment to help me say this, 107,568. Ooh, that's a big number. All right, so we worked with 18,878. We had a lot of fun working with that place value because we're really working on making sure we understand that place value. Let's go ahead and move into our task today, working with fractions. All right, so we have here different fractions. You noticed last time we were working with figuring out what one piece of like 4, a grouping of 4 of a whole, or we did a number line yesterday, working out how to place those numbers on a number line. Today we're taking that and now we're adding some decimals. Whoa, fractions, I don't know where decimals came from. So our question is which of the following sums are equal to 22/17? Ooh. If I was to rewrite this, because sometimes when we're typing, we can't always get a very nice look, but this is how we would write it, 22/17. So now it looks a little bit better for you for what we're used to seeing from fractions. Typing sometimes isn't the best thing, but it's there for us. So how would we do this? How would we figure out which of the sums are equal to this? Do we add, I heard some of you, do we add the numerator? Do we add the denominator? Do we add both of them? What do we do? Right? You can't add that denominator. That's one thing that we're not allowed to do because the denominator tells us how many pieces of the whole. So it's just telling us of the whole. It's not telling us how much we have. So we're not allowed to touch that. Just leave that denominator alone. So let's work with the numerators. So our first one is we have 5/17 plus 4/17 plus 3/17 plus 10/17. Again, I have to leave my denominator alone because it's just how many pieces of the whole is there, not how much we have. All right, so we have 5 plus 4 plus 3 plus 10. Remember how I told you we could add them in any order? That's what I'm going to do. So I know 5 and 4 makes 9. Oh, I forgot to remind you, I did earlier. Did you all know that you could download these tasks from online? Try it out yourself before you have me go over it. Make sure to do that. Don't just do it with us because remember, we're trying to work with your thinking and then you're just wanting to check your work against mine. Okay, so I know I have 9 and I know this is 10. So if I add 9 and 10 makes 19. And then I just have to add 3 more. 19, 20, 21, 22. Okay. I have 22/17. You notice I'm almost sounding like a snake because I got to put my tongue between my teeth to say the THS. That tells us it's a fraction versus another kind of number. All right, so did we work? A is one of them. I'm done. I got it. Yeah. Anytime you have a task that's asked you that, you better double check your work. Because sometimes there's not just one right answer. Sometimes, like this one, there's multiple right answers. Or I may be wrong, but I always double check. All right, so let's add this one. We know we're going to keep the 17ths. So how many do we have total on the top? I know I have 6, 3 and 3 makes 6, plus 8, I know that's 14, and if I add 14 plus 10, 24. So does that equal my 22/17 that I have there? No. So I'm going to cross that one out. All right, again, we have 17 as our denominator. Just add them up. Well, I know 6 and 4 make 10, and I know 5 and 3 make 8, plus 2 more make 10, so I have 10, 20, 22. So see, didn't I say just double check just to make sure? That's why. All right, the next one. I have 12 and 10. What does that make? 22. You guys are quick on this with me. All right, let's look at the last one and double check our work. We know we have 9 and 1 make 10. You notice I always like to make 10s if I can, or doubles. Just makes it easier. 9 and 1 make 10. 1 and 3 make 4. So that's 10 and 4, 14. So nope, that one is not it. Now this next one, you're going to come up with 2 or 3 possible solutions that could work. I'm going to come up with a couple, check to see if yours matches mine or if you came up with something different than me. So it says, find another way to write 22/17 as a sum of fractions. So that's just like what they did here. And they asked us to come up with different ones. Well, I'm kind of weird, and I kind of liked these 2 right here, so I'm going to do another one like that. But again, I have to have different numbers. So I'm going to have my 17ths and my 17ths. What 2 numbers could I use that would work to make 22? Well, I like 10 and 12, but that's not going to work. It's already there, right? Could I go up or down on one of the numbers? Let's go up one from 12, 13. So what would I need from this, knowing I have to make 22? I probably should put my answer in there, right? You guys were probably telling me that all along. So what do I need to add to 13 to get to 22? Well, I know I added 1 here. Could I just subtract 1 from 10? Let me try that and let me double check my work. So I have 9 and 3 make 12 plus 10, 22. That works. Okay, perfect. All right, some of you are saying, Miss Gaudette, try 3 numbers. All right, we'll try 3 numbers. So I have 17 plus 17ths plus something. 17ths has to equal 20. I'm going to get it really tight in there. 22 17ths. What number should I start with? 4. Good suggestion. Can someone give me another number that's not above 18? Oh, I heard 11. Thank you. So I have 4 and 11. What does that make? 15. So I need to add something to 15 to get to 22. What could I add? 7. Thank you. Did you come up with the same ones as me? Some of you may have. Did some of you come up with different ones? Yeah, there's many, many possible solutions to this answer. All right. And again, if you only come up with one, I want you to try harder and not try harder. Come up with a different solution because I want you to push that brain of yours. All right. All right, here we go. Now we have some more fractions. Cynthia is making her famous perfect punch for a party. She's probably having a birthday party or friends over. After looking through the recipe, Cynthia knows that she needs to mix 4 and 5/8 gallons of fruit juice concentrate with 3 and 7/8 gallons of sparkling water. All right. Any information there for us yet? Do we know what we're being asked to do? We don't know yet. Do we have some numbers that we think might be something we need? Yeah, the 4 and 5. We have the 4 and 5/8 gallons of fruit juice and the 3 and 7/8 gallons of sparkling water. Perfect. All right, so we don't know what we're being asked. We have to read more. Just as she is about to get started, she realizes that she only has one 10-gallon container to use for mixing. Will this container be big enough to hold all the ingredients? Do we know what we're being asked? Right? Is it going to be big enough? What other information were we given that we need to know? The 10 gallons, thank you. So we know we have 10 gallons. And we're asked, knowing that we have 4 and 5/8 gallons and 3 and 7/8 gallons of sparkling water, do we have enough? So right now, what this tells me is I need to do my estimation skills and give me an idea of what I need to do if I have enough. So 4 and 5/8, if I was looking at that, based upon yesterday, and we were doing a lot of rounding yesterday, is 4 and 5/8, what is that closest to? Is it closest to 4 holes or is it closer to 5 holes? So the 5/8 is what we need to help us out. That 5/8 tells me I have 5 pieces out of a total of, I'm getting my fingers right, 8 pieces. So if I have 5 out of 8, is that closer to a whole, closer to 2 wholes? What's going to help us out is we have to look at the denominator. If I have 8 as all the pieces and I got 5 of them, did I get 0? Am I closer to 0, a half, or a whole? What happens is, what's half of an 8? 4. 5 is bigger than 4, so I know I'm going to have to round up on this one. So I'm going to say this is equivalent to 5 in my rounding. No, it's not, but we're just saying for rounding purposes that we estimated 5. So we have the next one, 3 and 7/8. What is that closer to? Is it closer to 3 wholes or is it closer to 4 wholes? Again, right? Yeah, you guys say, well, Mrs. Gaudette, you told us denominator. Yep, look at the denominator. Is 7 closer to 8 or closer to what I would say 0? It's closer to 8. So we would round that up also. So that's equivalent to 4. So I know I have 5 plus 4 is 9. Do I have enough to make that 10? Yes. Yes, we will have enough. And you guys are all, a lot of times when I have worked with people, they're like, do we really need to do anything? We just proved it with our math. But when other people are looking at your work, sometimes they don't know your thinking. So by you showing with your math and then saying yes, tells me you have complete understanding of this. That's why we add in both of those, the written form as well as your work. Our next question says, how much punch will this recipe make? Oh, now we got to do some math here. So I have 4 and 5/8 plus 3 and 7/8. What does that equal? Well, I'm one of those ones where I like the whole numbers because it's easy, so I add those first. 4 plus 3 is 7. Now let's go to our fraction. Right? We have 5/8 and 7/8. I know my denominator will not change, right? Because it tells us how many pieces are in the whole. So we can't change that. So we will leave ace alone. So we have 5 and 7 make, do a quick calculation, splitting up the 7 into a 5 and a 2 to help me out here. So we know we have 12. We have 7 and 12/8. Well, I know my 12/8 is bigger than a whole. So I'm going to split this up. So I know how much makes a whole if my denominator is 8. Right? It's 8. And then how much does that leave over? 4. So I have 7 plus a whole plus 4/8. Good job. We have 8 plus 4/8 is our total. All right, guys, so we're going to be moving in to working with finishing up our activity from Pigs Will Be Pigs. And we are then maybe, depending on what's going on, might start a new book today.
Let's see. All right, let me move along through this. Okay, so yesterday, hi, my name is Mrs. Sears, and we're going to just recap what we did a little bit yesterday. Yesterday, we read a book about Pigs Will Be Pigs, and it was fun with math and money. So we're actually going to kind of use that decimal. I know that we were talking about making sure that we said the and when we have a decimal. So we're going to be actually using that decimal, but we're going to be trying to figure out how much money did the pigs find in their house. Remember, if you thought about the story before, they had no money or no food in the house, and they wanted to get something to eat. They wanted to go out to their favorite restaurant, that enchanted enchilada. So they had to look around their house, and as they were looking around their house, they found these amounts. Mr. Pig first had $1 in his wallet, and then when he went up to his room, he found a lucky $2 bill in his socks. And then Mrs. Pig, she was looking around in the bedroom. She found first 2 nickels, then she found 5 pennies, and then she found a quarter, right? And then they went downstairs with the piglets, the piglets were in their room, and they found 6 dimes, 60 cents, right? And then they found a dollar bill that was on their bookshelf. And they had a penny collection. How many of you have the penny collection at home? Maybe it's in a piggy bank. Yeah. And that was $2 worth of pennies when they counted it all out. And then Mrs. Pig and the piglets, they went into the hall closet. They started looking through coats. They started looking inside the pockets. And they found 4 quarters, 10 dimes, a 50-cent piece. That's kind of a cool thing. And then we also had 17 pennies that they kind of scrounged together from there. Mrs. Pig, from that point on, went into the laundry room. She found a wet $5 bill that was still in the laundry. And Mr. Pig went down to the basement and found the big bucks, which was the 20 bucks that he found in his toolbox. So we were trying to figure out how much money in all did they find together. All right, well, if we're looking at just trying to figure out what Mr. Pig had done, he had a $20 bill, a $2 bill, and a $1 bill. That was $23. Yeah, it's pretty easy math. We can just do those whole numbers really quickly. All right, Mrs. Pig, what did she have? Well, we're going to want to do that $5 bill first. We're probably going to want to do our quarter next. That's $5.25. Probably would add maybe that nickel to make it more of a friendly number. So that 25 plus that nickel would be $5.30. Then we can add the other nickel, $5.35. And then again, the 5 pennies is going to give her $5.40, right? And I am saying that and. It's okay to say that and now, right? All right, the piglets. Let's start with those dollars, right? We have $1. And we also knew that the penny collection made a total of $2, right? So that's $3 already. Then all we'd have to add in would be our dimes, 60 cents, right? $3.60. And finally, Mrs. Pig and the piglets, we had $1 in that quarter. Remember, 4 quarters is $1. 10 dimes is also $1, so that's $2. 50 cents for that 50-cent piece. And then 17 extra pennies gives us $2.67. Wow, it's a lot of money. They had a lot of money to start thinking about that they wanted to go out to eat with. All right, so let us figure out how all of those add up together. Let me go ahead and get a little squiggly up here. Do you guys remember how much Mr. Pig had? $23. Okay, so we would write that just like that, our $23. Remember, we would have the 2 and the 10s, and then the 3 and the 1s. Did he have any change? No, he didn't have any change, right? What did Mrs. Pig have? $5. Would I put that over here in the 10s? Nope. I need to make sure I sort this correctly according to my place value. So I had 5 ones, right? Well, it's technically a $5 bill, but it would equate to 5 ones. And she had 40 cents, right? So that would be like 4 10s, no pennies, right? No ones there. The piglets, they had, let me think, it was $3.60, I think, right? Let's see, $3, that's gonna go in our ones. 60 cents. So far, we don't have any ones happening, right? Any of these pennies that are happening over here. And then Mrs. Pig and the piglets, they had $2 and I believe 67 cents. Because that was the 4 quarters, the dime, I remember the 50-cent piece and the 17. All right, how would we figure out how much money they had all together? We can kind of use that algorithm that we were doing earlier before, and we may have to do some regrouping. Let's see if we are going to have to do that. So if we're looking at our pennies, how many pennies did they have all together when they combined all their money? They had 7 pennies, okay? It's just 7 plus 0, so that number's not going to change. What happened over here in their amounts with their dimes? We had, I can already see if I know my complement numbers that a 4 and a 6 is going to be a 10. So I'm going to already have to regroup this. All right. So we have at least 10 of these are going to be dimes, which is going to tell me that I'm probably going to need to make $1. And then I have 6 additional ones. Now remember, we can't keep 16 in there. We can only keep one space for one digit, right? So I'm going to keep that 6 behind. And I'm going to regroup those 10 dimes. It essentially could be 10 dimes that I'm going to have to regroup, and I'm going to have to put it into the dollars, right? All right. So now let's take a look and let's see what we can do here. Are there any numbers that kind of point out to you, like Miss Gaudette was kind of decomposing the numbers? Are there any numbers that look like they'd be really easy to put together? I mean, I'm looking at this 3 and 2 and then this 5. Because I know 3 and 2 are 5, and then another 5 would be, yes, another 10, right? So we can regroup that. So if we have $10 at least there, then we need to add that other $3. Don't forget the $1 that we had to regroup from our dimes. So we're at 14, right? We're going to leave. Yep, we got to leave that 4 in there because we only have space for one digit. And what do we do with those $10 that we had extra? Oh, we have to put that into our tens, right? And our $10. Okay, so that leaves how much money in his tens that he had, or that the family found? 30, right? They had $34.67. Wow, that's pretty good money. I like that. All right. Now, let's see if we were correct on that, because the pig family did have $34.67. Good thing to say that. And how much money did they spend at that enchanted enchilada? Remember, what did they order? They ordered that special. Yeah, and how much money did they have left over? Oh, let's go back and see this. Okay, I remember the special. This is a really good special. They get all this food, the chef's soup, the enchilada, the guacamole, the chimichanga, unlimited salad bar, a smoothie, a sopapilla or deep fried ice cream, or coffee or tea, and they could do it for $7.99. And tip and tax are included. Boy, that's a bargain if you ever tell me, and that's a good one. So $7.99, but they have $34.67. Did they have enough money to buy everything? I don't know. We're going to have to think about that. First thing we're going to have to figure out is how much money were all those dinners, right? So if we're thinking $7.99, make sure I have that on again. I kind of look at this. I'm one of those folks that I like to estimate, kind of like what Miss Gaudette was doing in the last thing. I'm going to think about what that number could be. So that number, to me, is really like $8. So she kind of did like one of these symbols. I've done it as an arrow and stuff before, but that's really like $8. How many people were in that family? Well, we had Mr. Pig, we had Mrs. Pig, and we had those 2 piglets, right? So 4 people in the family, right? I'm guessing those piglets must have been twins. So if I thought about that $8 roughly, and I did $8 times those 4 people for each of their meals, because they ordered 4 specials, about how much money were we talking? Like $32, right? Because we know 8 times 4 is 32. All right, let me make sure I keep my unit correct there too. But I got to account for something, because that wasn't really the exact amount of money that they made or that they spent, right? Because it was $7.99. And remember, I rounded up. I kind of tried to get to a friendly number, a better number that I can help work with on my math. It's really only a difference of a penny, right? So if I was to take that $32 and just take away the 4 pennies that they didn't have, from the 4 of them, I would actually end up with a real amount of $31.75. $32.96. And I did that by counting back from my $32 because I know from $1, that's like 100, and I just counted back 4. So I knew that was about what they spent, okay? Or that was exactly what they spent. Now, how would I do this in terms of thinking about it? I could put it back into that standard algorithm form. But to me, I think about this again on an open number line. I really like to kind of think about it like they started here at $31 because we need to figure out this next part. And I always do this wrong. So how much money do they have left over? That's really what we're trying to figure. We figured out how much money did they spend. Now we're trying to figure out how much money did they have left over, okay? So if they started with $31.96 and they had to get to, or they had originally that $34.67, how much money did they have left over? I'm gonna kind of do this, like I said, more of an open number line idea. So if I was, again, think back to what we did here to figure out that amount, I'm gonna get to that next friendly number, okay? So if I only need 4 cents, and I think that's how you write it, if I only need 4 cents to get to that $32, right? Let me put that 32 down here. Maybe I can do it like kind of I just made a quick little jump over there. How much would I need to get to the 34? I can make a big jump, right? Of that $2 just to get to that 34. And then I just need how many more cents? 67 cents to get, okay, decimal, to get to that $34.67, right? All right, so how would I figure out, I'm gonna leave that part with you. How would I figure out how much money they would have left, right? I could just add those pieces together to help me figure that out. My $2, my 67 cents, and my 4 cents would be that $2.71. All right. I do want to have time. I know I have just a few more minutes. I wanted to kind of read our book, but we can probably get to that tomorrow. It's going to be a really cool book. We're going to learn a lot about some division when we're thinking about it. All right, let me get out of this because we want to get to our game board. Boom, boom. All right, I got to go through that. We'll just keep that in there for tomorrow. All right, so we have a really cool game for you today, okay? This one kind of was supposed to go a little bit along with the book because we were maybe talking about remainders, and I know we've heard that word remainders before. Ms. Gaudette might have remembered, might have talked to us about that vocabulary word before. But what we're going to be doing is we're going to be playing a game called Remainders Race. Ooh, sounds kind of fun and interesting. Mm-hmm. Let me actually get our colors up so we have those. So let me explain how this game works. Do you see the start? Yeah, we have to start at 43, and we have to get all the way down to the finish line, which is at 36. The first one of us who can get to that finish line is going to be the winner, okay? But let me explain what we have to do and why this is called Remainders Race. So if you don't have, if you have a 9-sided die and you want to, use that, you can use that. But if you don't have it, you're going to use a spinner. And we have attached this on our lesson resources, so you can have this available if you need it.
There's also spinners online if you just Google a 9-spinner, and you can find them also
And that's
online.
What we're using here. And then you would just need like a paper clip and a pen or a pencil, and then as you spin, you would just kind of flick your finger there, and it would land on whatever number that you would need 1 through 9, okay? But in our case, we got a spinner, so let me explain how this is gonna work. Okay, so we're both starting on 43. What color do you want to be, Miss Gaudette?
I'm always red.
You're always red? Okay, so I'm gonna put red, and I'm just gonna mark it as an X, okay? So I'm gonna be the blue.
Okay.
All right. Do you want to go ahead and spin that spinner? So the 43, if you remember some of our vocabulary, is our dividend. Okay, that's the number that we're going to be dividing up, okay, into how many pieces, which is our divisor, is going to be the number that Miss Gaudette spent on the spinner. So she has 43 divided by 6. How much is that?
Well, 6 can go into 42 7 times.
Okay, and so it goes into 7 times. How much is left over?
1.
1, because 6 times 7 is 42. 43 minus 42, you're going to be able to move 1 space over. You move the amount of space that is your remainder, okay?
We're going to have to double check each other's work.
Yeah, so she started here, so she's actually here now, okay? So the next time when you spin, whatever number you spin, you're going to be, this is your dividend, and that number you spend, your divisor, is going to be what you're dividing it by, and you move the amount of space of your remainder.
Okay.
Now, what if she had, I'm just kind of doing a for instance, but what if she had rolled that, spun that 6? If she had a 30 divided by 6 and had a 5 and it went in evenly and she had a 0, she wouldn't just be staying there.
No. That means I can go 5 spots.
So she's got to think better than to roll that, correct? All right, would you mind rolling for me? I'm starting at 43, okay? Next player, we're going to alternate through our turns. All right, 43 divided by 9, okay? So I've got to think about my 9's facts. What's the 9th fact that's going to get me closest to 43?
Without going over.
Without going over, thank you very much. That was a good point. I'm going to say, I think I can do 9 times 4, which is 36, because if I did 9 times 5, I'd be looking at 45. That'd be too much, right? So 9 times 4 is 36. 43 minus, wow, this is a lot of math. We could be writing it down. 43 minus 36 is going to be 7. So I can actually, am I doing that right?
Yes.
I can actually move 7 spaces. So
all right, kids, you know this is not fair. How does she always get to move more than I do?
6, 7. Okay, so let me get my right color here.
Now you can put mine.
So I am right here. So my next time when I roll, whatever I spin, I'm going to have to, this is my dividend, 31, and I'm going to be dividing by that divisor, whatever I spin. Okay, so Miss Gaudette is on 30.
30 divided by 7.
All right.
All right, hold on.
Without going over.
7 times 2 is 14. 7 times 3 is 21. 7 times 4 is 28.
You want me to write this out?
28.
Okay.
So I know that 30 minus, because, see, I'm thinking the number that how many times it went in doesn't matter anymore, so I'm not even caring about that. I'm thinking 30 minus 28 is 2, so I can move twice.
Okay.
Do you agree with my math?
I agree with your math. So we're worried about the remainder. The remainder was 2. She could move 2 spaces, and now she's on 47. So the next time she spins, that's the dividend. She's going to pick a spinner part that's going to be her divisor, and we're going to have to figure out the remainder again. I'm on 31. Okay, 31. How many times can I put 5 into 31 with hopefully having a remainder? I think I can do that. So let's see, 5, 10, 15, 20, 25, 30, 6 times. All right. And 31 minus 30 is 1. See, this time didn't get to move very far. But that first one really helped me, right? All right, you ready to go?
All right, so I'm on 47. Yes, I'm on 47.
Ooh.
Oh, 47. Okay, 2 can go into 40 20 times.
This is kind of neat. This is a big number that you could be dividing by.
I know, right?
Yeah,
20 times.
She's really wishing she could use the divisor now and be already out, right? Okay.
Yes.
No, see, she's cheating.
All right, so it's 20, 22, 24, 26.
Okay.
So it's 23 times.
So you said you had 47. Oh, I'm on 47 as well. We're talking about divided by 2.
I'm saying is 23 times.
Okay.
So that makes 46. So I can only move it
I
once.
almost feel like I can do that because let's see, 23 times, because it's approximately 23 with a remainder of
1.
1. All right. So 23, let me think. 23, 20 times 2 is 40. 3 times 2 is 6. 40 plus 6 is 47. I did this partial products, right? She's got 1 left over. I got that. All right. My
She's
turn.
really checking my math there.
I have to know. I have to know. All right, 47.
Yes!
What's happening here? Well, 47 will go evenly into 47, or with 1.
One will go evenly.
47 times. I just stay where I'm at.
All right, I'm slowly
So,
moving.
did not get a remainder on that. It went in evenly. Got lucky. You just spin that on purpose, huh?
Of course. All right, so I have 29
Okay.
divided by 4.
29 divided by 4.
And I know that 7 times 4 is 28. So 29
Oh, we did that up there.
Yep. 29 minus 28 is 1.
All right, so you can go 7 times with a remainder of 1, right? All right, so she's moving 1. She's getting there slowly but surely. Okay, better than 1. Come on. All right, 6. Let's see. So I have 47 divided by 6, right? So let's see. How many times can 6 go into 47 without going over? So let's see. 6.
It's only going over. She can only go over, so she loses her turn.
Let's see, 6. I don't think it's 8 because I know 6 times 8 is 48. So we have, I'm going to say 6 times 7, 42, right? So I think it's approximately 42. How much would I have remainder? So I have 47 minus 42, 5. Good job. All right, so let me see. 5, 1, 2,
All right, kids.
4,
How does she
5.
always get these bigger numbers? It's always.
It's not rigged. She's the one spinning.
It's rigged. It is rigged.
How could it be rigged?
Well, just like when you roll the dice, you always seem to get higher
I
numbers.
stayed there. I think we only have a couple more times anyway. Okay.
I know it's going to remainder 1 because it's always an even answer. This is an odd answer.
Okay.
1.
So you had 15 divided by 2, 7 times, right? I'm thinking 14. And you're 1 more over. All right. Well, at least you didn't get the 46. You would have been stuck there.
I know.
All right.
I know.
Then for me, 35. I think we got 1 more turn left of this, and then we can recap how this is a really cool game.
I like this game.
I do too. I think it's really neat. Okay, 3. Can 3 go into 35? I think it can. I know that we can do 10 times 3 is 30, but I actually probably could go another 3 because I had 5 left there, so that's 11. So 33 is 11 times 3, so I have 2 left over, right? So let me go. I am right here. All right.
All right.
You think that's it?
I think that's it because I did go first.
Okay.
So
All right.
make it
Well,
fair.
I did get a little bit closer than Miss Gaudette did. But you really want to try to finish that. And that was a really cool game that we had to do. All right, so let's kind of recap a little bit of what we did. So we had our number of the day. We also were doing a lot with fractions where we were decomposing that fraction. That's a bigger word, right? Then we got to finish our story that was about pigs will be pigs. And really got to see how much money they had left over when they did get
How much money? I was wondering how much money they had altogether.
Altogether, it was a good ending to it. And then we had our remainders race, which was a really fun game involving division, where you're trying to find the dividend and divide it by the divisor so that you can have a remainder of hopefully to get like back and forth through on that game board. So definitely something that was really kind of cool for us to be doing.
Yeah. It's a lot of fun.
Tomorrow, if you didn't get a chance to have us read the story today, I'm going to read you a story called The Doorbell Rang. And we'll have some more activities to go along with that. But we really enjoyed our time with you today, and we want to thank you for joining us at home with APS. Hope you have a wonderful day. We'll see you later.
Have a great afternoon. See you tomorrow. Bye.